Hello students, welcome to a very important session of physics, refraction through a lens. In this unit, we are going to learn about what are lens, different types of lens, some terms related to lens, how the images are formed by lens, lens formula, magnification and applications of lens along with some practice questions. So today's session we are going to learn about lens, type of lens, terms related to lens. So let's get started. When we talk about lens, the very natural lens we found is our eye. Sometimes we use artificial lens to correct the eyesight defects, and we are so much surrounded with lenses. We have different types of lenses for different purposes. We use lens for magnification purpose like magnifiers or microscopes, microscopes, telescopes to get the more information about the world which we cannot see through our bare eyes. We use lenses to get the clear picture of that. We use lenses for the correction. We use lenses for cameras for capturing our precious moments and make a memory out of it. So we are surrounded with lenses and different application of lenses in our day-to-day life. So let's try to understand what are these lenses, how they are behaving, and how we are getting all these applications using those lenses. Lens means it is a transparent refracting medium which is bounded by either the two spherical surfaces or one surface spherical and other surface plane. So lenses are basically spherical surfaces which gives the refracting medium for the light which passes through it. So what is refraction of light? The refraction of light is a phenomenon of light where when light passes from one optical medium to another optical medium, it changes its direction or it changes its path, and these spherical surfaces will make the use of it where the light passes from air medium, and lenses are made up of glass or some transparent material, and light will pass through that where the lens is also optically uh, uh, which is transparent medium. So the refraction happens and the lens will give a transparent refracting medium to the light, and it gives the result what we are actually looking for. So lens is a transparent refracting medium bounded by either the two spherical surfaces or one surface which is spherical and other surface plane. So let's try to understand what are the different types of lenses and how they are doing. So a plane surface can be treated as a spherical surface of infinite radius of curvature. So when we talk about plane surface is also a part of a very large spherical surface whose radius is at infinity, right? So the lenses are spherical surfaces. Now we use different type of lenses. In that, the lenses are categorized in two kinds. The one is converging or convex lens. Convex lens is what convex lens is and how it converges. We'll just try to understand it. The another type of lens is diverging lens, or we also call that as concave lens. So lenses are basically categorized in two types. The convex lens, which is converging the light, so we call that also as converging lens. Concave lens, which also diverges the light, so we call that as diverging lens. So these are the main two types of lenses. In converging lens or convex lens, how we understand that one is a convex lens? If a lens is thick in its middle part, can you see here? If I take a lens, its middle part is thick and the edges are thin. So a convex lens is thick in its middle part and thin at the periphery or edges. A lens which bulges out in the middle. So they are bulging out in the middle portion of the lens. Such lenses are known as convex lenses. When a light beam converges on passing through such a lens, that type of lenses are called as converging lens, and the convex lens will converge light. So usually the converging lens is a convex lens. So when a light beam falls on a lens, all the beams will all the light rays will meet at one point after refracting through that lens, and hence it is known as converging lens. Can you see here? When a light rays fall on the lens, it gets refracted, and that refracted light will meet at one point. All the refracted light rays are meeting at one point, so they are known as converging at that point, and such phenomenon is known as converging of light, and these lenses will converge the light, so these are known as converging lens or convex lens, where its middle part is thick. Can you see here? Its middle part is thick and edges are thin, or it is bulgy at the middle portion. Now, converging or convex lens may be of the following three different types. When we take the converging or convex lenses, they are again categorized in three different types. One is biconvex or double convex or equiconvex lens, where the lens is having two spherical surfaces attached to one another, and it is creating a bulgy middle portion and thin edges. Second type in this converging lens is plano-convex lens. Here, one part of the surface of the lens is plane surface and another part of the surface is convex, that is thin at the edge and thick at the center. The third one is concavo-convex lens, or we also called as convex meniscus of that lens. So can you see here? This is the biconvex lens, where if I hollow this, then the both are the spherical surfaces and each are part of two different spheres, and they are attached to each other, so we call this as biconvex or double convex, or we can also call this as equiconvex lens. So this is a biconvex lens. In a plano-convex lens, one of the surface is plane and the other one is spherical. So here the edges are thin and the middle portion is bulging out. So these type of lenses are known as plano-convex lens. Concavo-convex or convex meniscus is one part is bulged and other part is scooped out from the plano-convex lens. It looks like that. But still it is thin at the edges and thick at the middle part. So this type of convex lens is known as cavo-convex lens or convex meniscus. So these are three different types of convex or converging lenses. Now let's try to understand about diverging lens or concave lens. So as it suggests, it is having a cave at the center, so we call this as concave lens. That means it is thick at its periphery and thin in the middle. So it is having bent inwards in the middle. In convex lens we saw that it is bulged out at the middle, but here it is bent inwards, or it has thin part or thin surface at the center. It diverges the light rays which are incidenting on it. So it is also called as diverging lens. It is diverging light. So when a light falls on a concave mirror or lens, what happens? The light rays will get uh, diverged outwards. So this lens is diverging the light ray. So we call this lens as diverging lens. So what is happening here? When a light falls on a concave lens, it diverges the light out, and if I extend that divergent ray, we feel like it is coming out from a point source. So this type of lenses which diverge light are known as diverging lens, and concave lenses are diverging light, so we call diverging lenses as concave lenses. Here it is making a cavey surface inside. Again, this is a part of a spherical surface where it is thick at the edges and or periphery and thin in the middle part. So this is about concave or diverging lens. Now, what are the different types of concave lens? Like convex lens, concave lens are also of three different types. So they are biconcave or double concave or equiconcave lens, where both the surfaces are concave in nature and they are part of two different spheres and they are attached to each other and they give a biconcave phenomenon. So they are known as biconcave or double concave. The second type is plano-concave, where one surface of the lens is plane and the other surface of the lens is concave. And the third type is convex concave lens, where it is scooped out to get a concave meniscus, right? So this is the biconcave lens, where there are two concave lens surfaces which are of two different parts of two different spheres. Plano-concave lens is a plane surface at one part and concave surface at another part. Concave meniscus, that means it is scooped out and made a, to look like a convex at one side and concave at another side. So this is known as convex concave lens. So these are the three types of concave lens which are available. Now let's try to understand some technical terms which are related to a lens. So as I told you, the concave or convex lens are the part of the spheres and we are taking the part of sphere and using them as convex and concave. So if I am taking two surfaces of sphere, then they are the part of two surfaces of sphere. If I am taking a concave lens where it is again it's both the surfaces are part of two different spheres. Can you see here? They are the part of two different spheres. So let's, before understanding what the lenses are creating images and how they are creating images, first let's try to understand some terms which are related to lens. The first one is center of curvature. So what is center of curvature? Here a sphere is, a lens is a part of a sphere. So the center of the sphere whose part we have taken for the lens surface, that center is known as center of curvature of that lens. Here we have taken two spherical surfaces. So it is creating two center of curvatures. In concave case also, each spherical surface of the concave lens is part of a sphere, and the center of that surface, which surface we have taken for the lens creation, that surface are known as center of curvature. So here if I am taking a biconvex or biconcave lens, it will have two center of curvatures for each surface of the lens. So what is center of curvature? The center of the sphere whose part is the lens surface is called the center of curvature of that surface of the lens. So we are taking lenses as the part of some sphere. So the center of that sphere whose part is the lens surface is called as the center of curvature of that surface of the lens. So this is first technical term, which is center of curvature, that is the spherical center of whose we have taken the lens surface. Clear? Now second part technical term is radius of curvature. So the radius of the sphere whose part is the lens surface is called the radius of curvature of that surface of the lens. So what we have learnt now? The surface of the lens we are taking is a part of a sphere. So the radius of that sphere, right? The radius of that sphere or the distance between the center of curvature to the surface of that spherical lens is known as the radius of curvature. If I am taking this lens surface, then this is the part of this sphere, and the distance between this and the center of curvature is known as radius of curvature of the surface of the lens. In case of concave also, we have taken the surface of the concave lens as part of some sphere. So we have already understood what is center of curvature. So the distance from the center of curvature to the surface of the lens is the radius of that sphere, right? The radius of that sphere. So that radius is known as radius of curvature. We have two spherical surfaces here, so we get two radii of curvature for the lens, biconcave or biconvex lens. So the radius of the sphere whose part is the lens surface is called the radius of curvature of that surface of the lens. Now, principal axis. So, when we take a spherical lens and if a point is passing through the center of curvature of that sphere whose part we have taken, or the line which is joining both the center of curvature of the both the surfaces of the sphere is known as, that axis is known as principal axis. So it is the line joining the centers of curvature of the two surfaces of the lens. So if there are two surfaces of lens, and if I have center of curvature for this surface and center of curvature for this surface, if I make a line to pass through both the center of curvatures of the lens, then that joining line is known as the principal axis. That imaginary line is known as principal axis. Now, what is optical center? The center of that spherical lens is known as optical center of that spherical lens. It is a point on the principal axis of the lens such that a ray of light passing through this point will emerges parallel to its direction of incidence. So, whenever light passes through the optical center, it goes undeviated or it emerges parallel to its direction of incidence. Such point on the principal axis of the lens that the ray of light passing through this point emerges parallel to its direction of incidence is known as optical center of that lens. Can you see here? O is the optical center of a convex lens and O is the optical center of concave lens, where that point, if I make a ray of light to pass through it, then it will not get uh, deviated and it will emerges parallel to its direction of incidence. So this point falls on principal axis and it is at the center of the spherical lens or convex or concave lens. Now, can you see here? When a light falls on, try to pass through this optical center, it passes undeviated or it emerges parallel to the direction of incidence in both concave and convex lenses. Now, it is a point on the, sorry, principal axis of the lens such that a ray of light passing through this point emerges parallel to its direction of incidence. So what is happening here? When a light ray falls on the lens, it first gets refracted and it is the light is coming from rarer to denser medium. So the refracted ray is bending towards the normal. If I draw a normal at that point of incidence, then it is bending towards the normal. When that same ray of light will fall on the other edge of the surface through optical center, then it emerges out parallel to the incident ray of light. So this point through which on the principal axis is known as optical center of the spherical lens. So the optical center of a thin lens is the point on the principal axis of the lens such that a ray of light directed towards it passes undeviated through it. Can you see here? If I am using a thin lens, then the point, the light ray which is falling on the optical center or passing through the optical center of the lens will pass undeviated or which will not undergo any refraction. Now, principal foci. So, what is happening here when we are making a some rays of light to fall on a lens, that all the light rays are converging at one point in a convergence lens, and that point is known as focus point. So, and that point will lie on a principal axis. So we call that as principal focus point of that lens. In case of divergence lens, what is happening here? When a ray of light or beam of light falling on the concave lens, it gets diverged. And if I extend all the divergent rays, they will meet at one single point and it feels like the rays of light are emerging out from that single source point. So this point of the concave lens, which is falling on the principal axis of the lens, we call that as principal focus point. So first principal focus of a convex lens and first principal focus of a concave lens. So primary or principal focus of a convex lens is defined as the point on the principal axis of the lens at which if an object is placed, the image would be formed at infinity. So if I take a point on a principal axis of a convex lens and if the light rays emerges out from that, the refracted rays after the refraction through that lens will pass parallel through that lens and they will get converged at the infinite distance. So that point on the principal axis is known as primary or principal focus of a convex lens. In case of concave lens, when a divergent beam of light falls on a concave lens, it after the refraction, it goes parallel. It travels parallelly and it creates image at the infinity. So such point where this extended incident rays will meet at one point on the principal axis, that point is known as primary or principal focus of a convex lens. So what is a primary or principal focus of a convex lens? It is defined as the point on the principal axis of the lens at which if an object is placed, the image would be formed at infinity. So the image will be at infinity. That means they are giving out the parallel beam of or parallel rays of light. So first focus of a concave lens is the point F1 on the principal axis of the lens such that the rays of light appearing to meet at it after refraction from the lens becomes parallel to principal axis. So the primary or first focus of a concave lens is the point F1 on the principal axis of the lens such that the rays of light appearing to meet at it after refraction from the lens becomes parallel to the principal axis. So this is principal focus point, primary principal focus point of the convex lens and first focus of a concave lens. Now, the second principal focus of a convex lens. If a parallel beam of light is falling on the lens, then the convex lens will refract the light rays and make them to meet at one single point on a principal axis. That point is known as principal focus 2 or second principal focus of a convex lens. So second focus or second principal focus of a convex lens can be defined as a point on which parallel rays after getting refracted from the lens will converge at one point and that point is secondary focus or second principal focus. Now in case of concave, if a parallel beam of light falls on the concave lens, after refraction it gets diverged and if I extend the divergent rays of light, they will meet at one point on the principal axis and that one point is known as secondary focal point for a concave lens. So the secondary focal point for a concave lens is point F2 on the principal axis of the lens such that the rays of light incident parallel to the principal axis after refraction from the lens appear to be diverging from this point. Which point? The second focal point of the concave lens. Now, focal plane. So, a plane which is normal to the principal axis and it is passing through the focus is called the focal plane. So a plane normal to the principal axis and that is passing through the focus is called the focal plane. So the lens will have two focal point or two foci of lenses, then the focal planes will be two. So a lens has two focal planes, one at a principal focus or primary focus and one at the secondary focal point. These are the imaginary planes. Now, focal length. So, the distance of focus from the optical center, the distance of focus from the optical center of a lens is called its focal length. If I if a lens has two focal points, then it will have two focal lengths. So, if I am taking a convex lens, then the distance between the optical center, if I take a plane at the optical center and plane at a focal point, the distance between those two planes is known as the focal length of the lens. So if I am taking it from the primary focus, so it will be primary focal length. If I am taking it from the secondary focus, then it will be secondary focal length. So the distance of focus from the optical center of a lens is called its focal length. And it has two foci, so it will have two focal lengths. Now, some important or noteworthy points which we need to remember in case of lenses. So, if the medium on both sides of a lens is the same, then its first and second focal lengths are equal. So, as I told you, there will be two focal lengths as there are two foci. So, one is a primary focus point and another is a secondary focus point. So, we have two focal length and two focal points. So, if I take the medium of lens before the light incident and after the light emerges out, if both the medium are same, then the focal length of the primary focal length and secondary focal length will be numerically equal to each other. So this is a noteworthy point or a point to be remembered, and it is important as per your numericals to solve the numericals. So if the medium on both sides of a lens is the same, then its first and second focal lengths are equal. Now, usually when we say focus, we mean the second focal point. Hence, the focal length of a lens implies the second focal length of the lens. So, when you buy or purchase a lens or when you are using it in the library, you'll see a note on that lens cover, that is the focal length or the focus of the lens, and it will be given in some numerical value. That numerical value will tell us that the length whatever is mentioned there is the second focal length or the distance between optical center and the second focal point of that lens. So it is the focal length of a lens implies the second focal length of the lens. In a convex lens has a real focus, while in a concave lens the focus is virtual. In convex lens, the point at which all the rays are getting converged and creating a real image, and that point we call that as focal point. So the focal point of a convex lens is a real focus point. So we call that as a real focus. In case of concave lens, what we are doing after the divergence, we are extending the divergent beam of light imaginarily, and they are getting converged at one point, or they are meeting at one point on principal axis, and we call that as focus point of that concave lens. Thus, it is not creating a real image, or it is not really making the rays to meet at that point. So, we call that focus as the virtual focus point of concave lens. So, convex lens will have a real focus and concave lens will have a virtual focus. Now, point number 4 here, only a beam of light that incident parallel to the principal axis converges to single point, or it converges at the focus on the principal axis after refraction through the convex lens. If the parallel beam of light is incident obliquely, it does not converge at the principal focus. It will not converge at principal focus. So, whenever we are trying to get a single line convergence, single point convergence from a convex lens, we should incident the light which is parallel to the principal axis. If it is not parallel to the principal axis, then we cannot get a converged image at focal point, right? So, this is a noteworthy point or very important point to be remembered. So, it will converge at some point which is parallel to that focal point or on any other point of the focal plane, but not at the focal point of the lens. Clear? If a parallel beam of light is incident obliquely on a concave lens, then after refraction, it appears to diverge from a point B in the second focal plane. So, similarly, if we are taking a parallel beam of light which is oblique or which is not parallel to the principal axis of the concave lens, then the divergence appear to happen not from the principal focus of the concave lens, but at some other point in the focal plane. Here they have mentioned B, but we can consider it as any other focal point in the focal plane of that concave lens, but not at the principal focus point, right? So, these are the noteworthy points. Now, let's try to focus on another point which is very important. The focal length of a lens depends on the following two factors. So, what are the two factors? The refractive index of the material of the lens relative to its surrounding medium. So, we already know refractive index. So, what is refractive index? When light travels from one optical medium to another optical medium, it bends. And if I draw a normal at that point, I'll get the incident angle or angle of incidence between the incident ray and normal at that point. And an angle will get created after refraction, and the angle between the refracted ray and the normal at that point will give me the angle of refraction. If I take the sin A of the angle of incidence to the ratio of the sin A of angle of refraction will give me a constant, right? Or the speed of light in first medium to the speed of light in second medium. This ratio also give me the same constant, and that constant is known as refractive index of the material. So, the focal length of lens depends on the refractive index of the material of the lens, which is relative to its surrounding medium. If my lens is in air medium, the refractive index of that lens, if it is made up of glass, then we'll take the refractive index of glass with respect to air medium. That is the refractive index of that medium. If a lens is placed in water, we have to consider the refractive index of the glass with respect to water, and that is going to increase the focal length, because the refractive index is increasing, so the focal length is increasing here, right? So the refractive index of the material of the lens relative to its surrounding medium will decide the focal length of the lens. The secondly, the radii of curvature of the two surfaces of the lens. A thick lens has less focal length than a thin lens of the same material. If I am taking a same material to create two lenses and one is a thick lens, that means it has a less focal length. That means it is the part of sphere whose radius of curvature is different, and if I am taking a thin lens whose radius of curvature is more, so I'll get a large or more focal length, right, of the same material. Say for example, if I am making a thick convex lens, right, if I am making a thick convex lens, if say this is the center of curvature and this is the optical center of that convex lens, then the focal point will be um, somewhere on the principal axis of this, and it is less, right? If I am taking a thin convex lens, so its center will be at the far distance and the radii of curvature is larger for the thin lens. So we get a focal length more in this thin lens case. Even though both the lenses are made up of same material and both have the same refractive index. So these 2 points will factors will influence the focal length of a lens. So it depends on refractive index of the material in which medium we are using the lens, and the radii of curvature of the lens will also influence or change the focal length of the lens. So these two factors will influence. Now, if a part of the lens is covered, its focal length remains unchanged. Only the amount of light entering the lens decreases, due to which the intensity of the image decreases. But the position, size and nature of the image formed by it will not change. So if I am taking a convex lens and I am covering it, or I am making this silvered, so its focal length remains unchanged. The focal length of this lens will be same. Also, the position, size and nature of the image formed by this convex lens will be same. What is changing here? Only the intensity of the image will change. What happens? It will decrease. So, the image will intensity of the image will decrease, but all other factors will remain same. Now, the difference between concave and convex lens. So, we also already learnt a lot of things about concave lens and convex lens. So, we know there are two different lenses. One is concave and convex. So, what are the differences here? So, a convex lens is thick in the middle and thin at its periphery. In a concave lens, it is thin in the middle and thick at its periphery. Convex lens is also known as converging lens because it converges the incident ray towards the principal axis. It bends the rays of light which is falling on it towards principal axis. In case of concave lens, we call this as diverging lens because it diverges the incident rays away from the principal axis. It is making, whenever a light falls on the concave lens, it tries to make that light ray fall away from the principal axis. So that is the reason why this is called as diverging lens. So convex lens has a real focus because it creates a real image of the lens at this focal point. So it has a real focus. It has a concave lens has a virtual focus because after the divergence we are imaginarily extending those diverging rays and we are trying to create a focal point here. So this is a virtual focal point, or it has virtual focus. So these are the differences between convex lens and concave lens. So in today's class we learnt about what is lens, what is refraction, and how these lenses are performing refracting phenomenon. Then we learnt there are two type of lenses. One is convex lens and other one is concave lens, where convex lens is also called as converging lens because it converges the light rays falling on it. And concave lens are the lenses which are called as diverging lens because it diverges the light rays falling on it. We learnt about different types of convex and concave lens like biconvex lens, plano-convex lens, concavo-convex lens. And concave lens are of different types as such: biconcave lens, plano-concave lens, and convex concave lens. So these are the different types of convex and concave lens. Then we learned some technical terms related to lens, where we learned about optical center, radii of curvature, centers of curvature. Then we learnt about principal focus, principal axis. Then principal foci. We learnt in detail about primary or principal focus of the convex and concave lens. Also we learnt about what is secondary focus or secondary focus of both convex and concave lens. Then these are some more points which are very much important to remember in case of lens. How to find the focal length, what are the factors that influencing the focal length, and if not a parallel beam of light is falling, then what happens, and all these details we learnt under important points to remember. Then also we learnt about the differences between convex and concave lens. With this, we learnt about the lens and its types with the technical terms. In next session, we are going to learn about how these lenses are forming images. So, let's get tuned for the second session. Thank you.